Let's use interpolation and extrapolation to predict values using the linear regression line. Here we have an equation that we had earlier. Y equals negative 0.00354x plus 37.3. We said the units on x was pounds because it was referring to the pounds of a vehicle, the weight of a vehicle, and y was the miles per gallon of that vehicle. Our slope, since it's y over x for our unit, is that number, and it's miles per gallon per pound. And then the y-intercept is the number of miles per gallon when the car does not weigh anything, when the car weighs 0 pounds, when x is 0. In order to predict how many miles per gallon a 3,500-pound car would have, all you have to do is plug in x equals 3,500 into this equation here. So let's do that. We have y, the thing we're trying to find, the number of miles per gallon, is equal to our slope times that x value of 3,500 pounds plus our y-intercept. And when you do that, you're going to end up getting 24.91. So if we had to predict how many miles per gallon a 3,500-pound car would have, we would say 24.91. Same idea down here. Let's do it again. Predict how many miles per gallon a 5,000-pound car would have. Well, 5,000-pound car, you're just going to plug in x equals 5,000. Same slope, same y-intercept, new value of x. So you plug in that value of x, 5,000 for 5,000 pounds, multiply it by your slope, add on your y-intercept, and for this one, a 5,000-pound vehicle, you would predict 19.6 miles per gallon. Now we're going to define two terms that explain what we just did. First one is interpolation. The key word, or the key part of this word, is the in. Interpolation. It's using a best fit line, which is what we just used, to predict a y value given the x value. So going back here real quick, we predicted y, we predicted MPG given x, given the number of pounds. So we were given one thing and we needed to predict the other. But here it says that falls within the min and the max x values. So the lowest x value that we had was a little bit over 2,400, probably about 2,600 was the lowest x value that we had from our original data. The highest x value was out here, 4,600 pounds. So somewhere between 2,600 and 4,600 pounds. Whenever you're making a prediction in that range, you're using interpolation. Extrapolation would be anything outside of that. So if we're thinking of x, such as external, you're thinking outside of this area. And here, I'll color this in yellow. Anything in this middle region here would be the interpolation. It would be inside the bounds of our data. Extrapolation would be predicting things outside of that. So when we look at our first example, predict how many miles per gallon a 3,500 pound car would have, 3,500 pounds falls right here, almost dead center in our data, right in the middle. It's because it's between the min and the max x values that we actually know, we're interpolating. Interpolating is typically very safe to do. Because we have all this data here, our line of regression is actually fairly accurate. As long as we have a decent value of r, we can say with reasonable mathematical certainty that interpolating is going to work many times. However, let's look at this other one. We said we predicted how many miles per gallon a 5,000 pound car would have. Well, 5,000 pounds is actually a little bit off the screen. It's just maybe right on the edge over here. So that's 5,000 pounds. Because we don't have any very good data that extends anywhere beyond 4,600, it's hard to know if 5,000 is actually an accurate prediction. Because it's very possible, for example, that even though this trend is going down, going down, going down, who knows if after this it flattens out. Well, that didn't help me. But who knows if after that the data were to flatten out. Or, for some reason, go up. Maybe because there's federal regulations at a certain size it has to go back up. Who knows what could happen out there. Your prediction only holds true within the data you have. You have no idea what's going on in the mystery region above or the mystery region below. Anything could happen. That's why extrapolating is very dangerous. So I'll uncover this here. Anytime you're extrapolating, anytime you're making predictions outside of this range, you're really treading on dangerous territory, if I had to put it some way. When you're making predictions into the future, you're bounded by the data you have up until the present moment. So you have so much data in the past, you have data up to the present, and you're making predictions on future data. When you do that, when you make predictions about the future, you are using extrapolation. You are extrapolating into the future. Many people earlier, many years ago, were predicting population growth into the 11, 12, 13, 14, 15 billions for planet Earth over the next 50 years. Because they were extrapolating, they didn't really know what kinds of things were going to happen into the future that could change population growth to be higher or lower. Turns out the more recent estimates are closer to 9 billion people as where the world population is going to start to level off just a little bit. Because of the fact that they're predicting things based on the past data, as things change, you have no idea how that future data is going to change. So you need to be very careful when you extrapolate. Interpolation is a much safer operation.